All right, hello everyone. Hi, Solon High School chemistry students. In this video, I want to take you through a number of physical and chemical changes. Now, this should be kind of our second experience talking about physical and chemical changes. You should have done some intro notes on them the day before. And we should all remember what a physical and chemical change are. So remember, a physical change is a change that doesn't change or doesn't alter a substance's chemical composition. All it does is maybe change its appearance, maybe there's a change in state, so melting or freezing or boiling, but we still have the same substance we started with. Where on the other hand, a chemical change is something that results in altering the substance's chemical composition. So in other words, we're going to change what the substance is. It's going to have a whole new set of properties after that chemical change has occurred. And in those notes, there was a mnemonic for remembering 5 indicators that we have a chemical change versus a physical change. And remember that mnemonic device is chemists get practice trying labs. So what do those represent? If you selected color, I need to cheat a little bit here. Chemists, color, get, gas or bubbles produced. Practice, P, precipitate. Trying, T, temperature change. Labs, L for light. So if there's a color change, temperature change, gas or bubbles are produced, if there's a formation of a precipitate, or if light is produced, that is an indicator of a chemical change. And what we're going to do is we're going to go through 11 demos today, 11 examples of this today. And for each of these, you need to A, make some observations on a separate sheet of paper, and then B, respond accordingly, answer the question, is it a physical or chemical change? So let's get started. Adjust my camera, show my workspace. There we go. Okay, number 1. I'm going to get some sodium bicarbonate. And I'm actually going to put it on a watch glass here. Boom, 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 some sodium bicarbonate. The watch glass is a little wet, but that'll be fine. And then I'm going to add some hydrochloric acid. And again, so let's make some observations. I add my hydrochloric acid. Whoa, wow, look at that fizzing. Look at those bubbles. I'll add some more. So what do we think? Chemical or physical change? If you selected chemical, you would be correct. Gas produced, indicator of a chemical change. Okay, need a test tube. Number 2. Start with some potassium iodide solution. It's a clear, colorless solution. I'm going to add some lead to nitrate to it. It's in the dropper, also clear and colorless. Oh, wow, look at that. As soon as we dropped in our lead to nitrate, we had production of a yellow solid. Again, kind of hard to see, but that is a yellow solid at the bottom of our test tube. So what do you think, chemical or physical? If you said chemical, you would be correct. And guys, this is a precipitate. When you mix 2 solutions together and you produce a solid. And you also had that color change indicator. So that's how we know it is a chemical change. Number 3, paper cup. Boom. Sodium polyacrylate, just a little bit. Sodium polyacrylate is a boom, 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 little bit, little bit, little bit. Is a white solid. And the one thing I forgot to prep, a little bit of water. Grab some water. I need this for a couple other ones, so this will be fine. So again, solid, add some water. And again, kind of hard to see. Add some more water. We add a whole heck of a lot of water. And again, kind of hard to see until I maybe start touching it. Now we have this kind of clear, solid, almost like Jello-like consistency substance. There we go. Oh, isn't that lovely looking? So again, after we added water, it kind of became this clear, Jello-like substance, or gel, actually. So what do we think? Chemical or physical? If you said chemical, you would be correct. That color change there tells us it was a chemical change. We actually use sodium polyacrylate in diapers. You can see it absorbs moisture, absorbs water really well. All right, so 3 so far and 3 chemical changes. Next up, test tube, and I want some milk in there. Boom, 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 pour some milk in my test tube. Then I want to add some hydrochloric acid. And then, just so we can better make observations, let's dump this out into a little baby test tube here. Oh, you saw some of those chunks come out, lovely. So now, again, kind of hard to see, but now instead of being all liquid, it's a little chunky. And it's actually giving off a really bad smell. So now that milk kind of turned chunky. You got a really bad smell that's being given off. Kind of see some of those chunks in the bottom of the test tube there. So what do we think? Physical or chemical? Chemical would be correct. We denatured the proteins in milk by adding the acid, which is a chemical change. Okay. Another small beaker. Number 4. No, number 5. We're on number 5 already. Okay, I need a small scoop of some citric acid. I'm just going to ballpark this. Some citric acid. And then I need some sodium bicarbonate, which is also baking soda. And I'm being so scientific about this. There we go. And now I need a separate beaker with some dihydrogen monoxide, basically water. So I got my 2 white powders, I got some water. Let me take the temperature of my water. Okay, this is warmer water than before. It's about 28.0, no, 29, about 29.0 degrees Celsius. And now I want to add my water, make some observations, and record the temperature. Oh, look at that fizzing, look at that bubbling. Clearly a gas being produced here. And let's record that temperature change. I kind of gave it away there. Oh, my new temperature now. It's about 25 degrees Celsius. Now it's down, yeah, 25 degrees Celsius. So I had bubbles produced. It fizzed. I had that temperature decrease. So what do we think? Physical or chemical? If you selected chemical, you would be correct. So 5 examples so far of chemical changes. All right, number 6. I need some iron 3 nitrate, FeNO3. It's an orange clear solution. Lovely, nice and orange. And to this, I'm going to add in some acid, some hydrochloric acid. And I did. And again, it might be hard to see from your angle, but now that I hold this a little bit closer, it turned to a lovely yellow color. So what do we think? Physical or chemical? And this is that original orange color, and now it is yellow after adding our hydrochloric acid to it. If you said chemical, you would be correct. That color change is a dead giveaway of a chemical change. Okay, number 7. Number 7, I need some sugar. Small scoop of sugar again. I'm not going to be so precise here. A little bit of sugar. And some dihydrogen monoxide. Okay, H2O. Let me add some water to it. And observe. Kind of dissolved a little bit. Some of it dissolved. There we go. We mix it a bit more. More of it dissolves. But there was no real bubbles. There was no fizzing. There was no color change, just dissolving. So what do we think? Physical or chemical? If you said physical, you are correct. Dissolving is very similar to a change of state. Therefore, it is physical. All right, number 8. Evaporating dish. Some magnesium metal. Just getting it off screen here. And then what I need to do, add some acid. You definitely want to make sure you can observe this pretty well. More hydrochloric acid to our magnesium. Bubbling, fizzing. You can see it, the gas being produced actually. Ooh, bit of a smell to it as well. The gas being produced has a little noxious. And then what you're missing, guys, is that it is also really hot to the touch. So it bubbled, it fizzed, it was hot to the touch. So what do we think? Chemical or physical? If you said chemical, you would be correct. We actually had that magnesium and the hydrochloric acid reacted. The gas that was produced was actually hydrogen gas, but definite chemical reaction. All right, another one. I need another evaporating dish. And what do I need here? I need some calcium chloride. Just a little bit. Tiny, tiny little bit. Tiny, tiny, tiny little bit of calcium chloride. I need a little bit of water. Correct? Yep, a little bit of water. Stir that around a little bit here. Try to make it dissolve. And a little bit of universal indicator. Now, we might remember indicators from our days of biology, where an indicator is going to be different colors based on the pH. And this is number 9, by the way. Did some extra drops there just so we could see the color a bit stronger, more clear. And again, we have that lovely greenish tint to it. Again, kind of hard to see with the way the light's working today, but it is a lovely greenish color. Okay. And now what I want to do is I'm going to add some sodium bicarbonate to this. Good old sodium bicarbonate. It says a small scoop. Again, I'm going to be so scientific this way. Here we go. I added a scoop. About. Twirl it a little bit. And again, we kind of saw it a little bit there. Again, kind of hard to see with this angle. But we're having a little bit of a color change. Maybe some light fizzing going on. Really hard to see. But again, color change there. Let's maybe try a little bit more. I know, so scientific. Don't do what I'm doing right now. And again, we mix it a little bit more. Okay, we're getting more of that reddish color in there now. We get a color change. So what do we think, physical or chemical? Well, if you said chemical, you would be correct. There's a reaction between that calcium chloride and sodium bicarbonate. It's a chemical change. And now for our last two, number 10, involves the Bunsen burner. So I'm going to go get the lights real quick. It makes it much easier to see this. Lights. And when I turn on my gas valve, out is going to come methane, which is a colorless, odorless gas. Actually, no, methane has a little bit of a smell to it. And there we go. That was that change. Going from that clear, colorless, to now kind of pretty obviously giving off light. So what do we think for number 10? Chemical would be correct. And then our last one here. Number 11, some more magnesium ribbon. And we're going to put our magnesium ribbon into the Bunsen burner flame. And then take a look at what happens as a result. Look at that, wow. I'm not staring at it directly, but we have some smoke being given off, a whole lot of light being given off. So what do we think? If you selected chemical, that would be correct. Magnesium, once we kind of used our Bunsen burner to give it that little bit of activation energy, reacted with oxygen in the air to make magnesium oxide. That would have been a chemical change. So kind of adding everything up, of the 11 changes demoed for us, I believe 10 should have been chemical, 1 was physical. Definitely make sure you know the 5 signs or the 5 indicators that a chemical change has occurred. Just remember, chemists get practice trying labs.